Traditional manufacturing often operates under a crushing physical weight, bogged down by excess raw materials that congest the production floor. For decades, companies built parts on strict preset schedules to create a protective cushion. This just-in-case method ensures the next operation always has materials to work with. This balance sheet shows how traditional planning categorizes that cushion. Because these materials represent future value, they are recorded as a positive financial asset. Just-in-time inventory planning rejects that classification. In the JIT model, idle inventory is viewed as a liability that drains resources. Instead of building toward a schedule, JIT limits output to the specific needs of the next station. A part is only produced when there is immediate demand for it. This moves the factory from a forecast-driven push system to a demand-driven pull system. When a company switches the production trigger from a forecast to an actual demand signal, it sets off a chain reaction that redefines how it manages its physical floor, its internal controls, and its costs. The primary danger of the traditional inventory buffer is its ability to mask systemic production errors. In a push system, Station A overproduces. Defective blocks are buried in storage. Station B continues working normally with good parts, ignoring the defect. But in a pull system, Station A stays idle until Station B requests a part. Only one is created. In a system with zero buffer stock, a single defect will trigger an immediate total halt of the production line. Without a safety pile, a defective part starves the next station of materials, forcing the entire operation to stop until the problem is solved. This shifts quality control. Don't discover defects after production. Prevent them at the source. Commit to zero machine breakdowns and zero defects per part. Force hidden inefficiencies to surface. Linear push systems use conventional plant layouts, where isolated departments house specialized machines performing only one task. To support JIT, the factory layout must change into manufacturing cells. Machines are reorganized from isolated departments into compact semicircles, grouped by product family. Each cell operates like a miniature plant. Parts move across different machines in close proximity, creating an unbroken flow. This physical restructuring necessitates a change in human resources. Workers can no longer be single-task specialists. Cell workers must be multi-skilled, capable of operating all machines in the cell, performing rapid setups, and executing quality inspections themselves. In a pull system, a single skilled worker would sit idle whenever the demand signal was absent. This environment relies on employee empowerment. Teams need authority to stop production without waiting for approval. This environment shifts the role of management from directing specific individual tasks to facilitating the needs of the entire team and actively supporting continuous improvement. Ultimately, the cellular layout is only as effective as the multi-skilled, empowered workforce that operates it. Shrinking the inventory buffer fundamentally alters how a company's costs behave and how it interacts with external suppliers. This table describes negotiating long-term orders for smaller deliveries. This lowers investment and reduces storage needs. These benefits decrease total carrying costs. However, without a cushion, stockout risk increases. As option D indicates, carrying costs decrease while stockout costs increase. This prompt addresses how JIT manages purchasing risk. To ensure frequent and precise deliveries, companies move away from broad competitive bidding to focus on deep partnerships. As option A highlights, this deliberate strategy reduces the total number of suppliers used. These trusted partnerships allow the company to eliminate central receiving areas and the administrative burden of hard copy receiving reports. Manual inspections of incoming goods are also phased out. Instead, quality is verified through statistical controls maintained by the supplier before the goods ever arrive. JIT replaces the expensive safety net of warehouse inventory with the operational precision of a highly integrated supplier network. This identifies the core benefit of JIT for raw materials. As shown in option A, the primary goal is the elimination of non-value-adding operations. Moving, counting, and storing inventory do not add value for the customer. Eliminating these steps is the central pillar of lean manufacturing. Lean manufacturing expands JIT principles to the entire organization, aiming to accomplish more with fewer resources. This circular diagram outlines the 5 principles of lean. It begins with identifying value, the features a customer is willing to pay for. Second is the value stream. Every process is examined to remove any step that does not directly contribute value. The third principle, flow and pull, ensures the process responds directly to customer demand. The cycle concludes with employee empowerment to make decisions and a relentless pursuit of perfection through continuous improvement. Just-in-time acts as the physical manifestation of lean management, a system designed to strip away the illusion of safety, expose operational waste, and drive relentless competitiveness.